I take the organizer that gave me the opportunity to share my work and the very nice program and the conference. So my topic is an organomagnetic multifunctional smart material. The objective of our work is to develop a conductive organic smart film that can respond to multiple stimuli like temperature, magnetic field, and multi-mechanical responsivity, as we have, as I will show later. And the device must be flexibility, simple to process, and cost effective. It is very, very simple to produce. We take a very common polymer that every lab used, polydimethyl-siloxane, PDMS. We blend this polymer with the other polymer, which is a conductive polymer, a polypyrrole, and we implant the nickel particles in it and blending, and we have this film. And this film can multiple response to multiple stimuli. And the thickness is around half millimeter, and it's very flexible. So when we check in a SEM, the cross-section SEM imaging with the EDMX, we can see that nickel nanoparticles is very, very homogeneous around the lattice, and another phenomena that the loading of nickel particles on the film is give us the performance of electrical performance. As much as you see here, we have it here in percentage by weight of the nickel in the lattice, as much the lattice with amount of nickel particles. We have a IV effect, which is a more with high performance. As you see here, when we have it around 35 or 30% by weight, we have a good performance of the electricity of the lattice. When we add high amounts of nickel, we can see degradation in some point after 800 of milligram per milliliter. So what I mean the multi-stimuli and multi-response, we start with the temperature. So when we apply a range of temperature from 0 to 100 degrees, we can see that the conductivity of the lattice is degraded until around 100 here in 100 degrees Celsius, we not have any electrical response. This was done in 1 volt when we apply 1 volt. But if we apply highest voltage, more than 1 volt, we have here, this is the 1 volt, this is a 4 volt, and this is a 10 volt. You can see that the electricity response is give the slow degradation if we apply highest voltage. I want to focus on this bar, which is the physiologic temperature window, and we can see that in this bar we have a very nice slope, and is dependent. We can moderate the sensitivity by applying the voltage. As we see in this plot, we can heating and then recovery is the response after we cooling. Here we cooling in a room temperature, but we can cooling by other way. So another stimuli is the magnetic field. The magnetoconductive behavior, we found very nice behavior on the magnetic field when we apply on the device here the permanent magnetic field. We can see some switch in a response of the device, and we can switch from on to off by apply magnetic field. The magnetic field we apply here is around 100 Gauss, which is 10 by minus 2 Tesla, and we can see the number of switch that we can apply with the magnetic field. We even check it in the electrochemistry environment and measure the rate of electron transfer in some redox probe, which is a pair of ferrocyanide, and we can see for CV, which has cyclic voltammetry, the difference between a control which out magnetic field and with magnetic field, and even in impedance spectroscopy, we can see that in with our magnetic field we have around 8,000 ohm, which is 8 kilo ohm, and with magnetic field 6 kilo. So another stimuli in the same lattice, in the same blending of material, we can even sense a few multi-mechanical response like strain, bending, and pressure. And as you see here, we take the lattice and the film and the strain the film in 3, 6, 12, 18, and 24, and 30%. I mean, percent is when we can take the delta divided by the L0, which is the length of the original film. So we can see the response, and we can modulate this response and sensitivity by applying a different voltage. The second mechanical response is the pressure. When we press in top of the lattice, we can see that we change the conductivity and change the current according to the strong of pressure. What we have here is a 1 volt on applying 1 volt. The current change at the constant potential bias of 1 volt upon gradually increasing the applied top pressure up to 200 kilopascal. And here we can see the old picture of the pressure when we apply a different pressure on a different voltage, and opposite the different a different pressure here in different voltage. You can see it in this, if you can see a 3D plot, which we have a high performance in high pressure and high voltage. The last is a bending stimuli. When we bend the film, we take the degree from 45 to 165 degrees. They can see if you have if we bend it, we measure the angle of this inside of the lattice. So when we bend in 45 degrees, we can see the highest response, and as we can see here in this plot, where in comparison between 1 volt and 2 volt, and 2 volt give us highest response. So we can see the multi-stimuli for mechanic application. So we can think about many applications of this lattice in bio, in wearable sensor for physiologic parameter, temperature, measure tensile in muscle for Parkinson's disease, and even cover some materials that we want to sense the cracking or some bending of the material for any safety issue. So if we conclude, and I don't want to go to all these items, but I want to only explain that if we want to know the mechanism, why is response to all these mechanical stimuli, what we think that what we have in a first slide. So in the first slide, what we see here, that if we add more and more and concentrate the film with the nickel, so we have more response in electricity and change the current. So if we take the lattice and pressure, bending, or strain it, in the point when we strain, in a point when we pressure, in a point when we bending, the concentration of nickel come to be higher, and the distance between the particles in this point is more close. This what we think why the all the mechanical response give us by all this type of mechanical application. So if we summary, we have lattice. We have a film that very simple to produce it, and we have many stimuli, many response in this very simple film. Thank you for attention.